Dear students, this is Kiran Kumar Velmula, Assistant Professor of Physics, Sri Rajarajeshwara Degree College, Karimnagar. In this video today we are discussing about the transistors. In the previous class we discussed about PN junction diodes and the working of PN junction diode in forward bias as well as reverse bias. On the basis of PN junction diode, we are constructing the transistors. Transistor is defined actually the device which can transform the resistance in the electronic circuit from one place to other place. The meaning of transistor in the Greek language is the transfer of resistance. If we take the transistor consists of three major regions. One is base region, second one is emitter region, and the third one is collector region. So already we discussed about the PN junction diode. PN junction diode, P acts as one terminal and N acts as one terminal. But here in the transistor, base region is nothing but the middle part of the transistor is known as base region. Similarly, emitter is nothing but the region which emits the majority charge carriers is known as emitter region. P-type material may act as emitter. If you consider P-type region as emitter region, the majority charge carriers holes and the minority charge carriers are electrons. So majority charge carriers holes are emitting from this region and entering into the base region. Similarly, come to collector region. The collector region which collect the majority charge carriers which is emitted by the emitter region. This is also, it may be P-type of semiconductor material, it may be N-type of semiconductor material. If collector is P-type, the majority charge carriers are P-type. If the collector is N-type, the majority charge carriers are electrons. Here, holes are the majority charge carriers in the case of P-type. That means every transistor is divided into three regions. The emitter region is one side and the collector region is one side. Both are combined with the base region. Emitter region is heavily doped because if more number of charge carriers are located in it, then only it emits more charge carriers which are collected by the collector. Similarly, base region is moderately doped or lightly doped. It is connecting emitter region, base region. Similarly, collector region is moderately doped. So in this way, the base is connecting emitter region as well as collector region, whatever it may be the transistor type. On the basis of doping process, the transistors are classified into two types. One is PNP transistor and the second type is NPN transistor. The classification of transistors. First one is PNP transistor. If N type of semiconductor material is sandwiched between N type of semiconductor material is sandwiched between two P-type semiconductors, then that material is known as PNP transistor. This is one way. And the second way is P-type material is added to PN junction to left side of the transistor, then resultant transistor is known as PNP transistor. Similarly, NP NPN transistor. If P type of semiconductor material is sandwiched between two N type semiconductors, then N type semiconductor material, or this is one process, or N type semiconductor is added to PN junction diode at right side, then it is known as NPN transistor. If you observe this diagram, so this is PNP transistor. The second diagram represents NPN transistor. This PNP transistor consists of emitter, base, collector. P type of semiconductor material acts as emitter, N type is base, again P type is collector. This arrow mark represents the conventional direction of the current. In the case of PNP transistor, the direction is from emitter to base. So if you observe NPN transistor, in the NPN transistor, emitter is N type, base is P type material, again collector is N type material. So observe very clearly here the conventional direction of the current in the case of NPN transistor from the base towards emitter. The main difference between these two diagrams is nothing but the direction of conventional direction of the current is opposite to each other. In the case of PNP transistor, it is towards the base. In the case of NPN, it is away from the base. This is the main difference between PNP and NPN transistor. Next, configuration of transistors. Actually, if you take single PNP diode, it consists of two terminals. One is cathode, one is anode, or one is P type, or one is N type. Similarly, if you come to the transistors, every transistor has three terminals. Whatever it may be the type of transistor. First one is emitter, base, and collector. The base acts as one terminal, emitter acts as one terminal, and collector acts as another terminal. Naturally, it has three terminals, but in order to connect this transistor device in an electronic circuit, these three terminals are not sufficient to get output clearly, because every circuit required four terminals, two terminals in the input circuit, two terminals in the output circuit. But in the transistor, only three terminals, one terminal is deficiency to connect it. To overcome this difficulty, we are connecting any one of these emitter, base, collector into output as well as input. So that terminal is known as common terminal. This configuration is known as common configuration of the transistors. And a transistor has a common configuration to connect the electronic circuit according to our convenience. So on the basis of configuration, because transistor has three terminals, emitter may be connected as common, base may be connected as common, so collector is also connected as common. Therefore, on the basis of the types of terminals, we are classifying those common configurations into three types in the case of transistor. One is common emitter terminal, one is common base terminal, one is common collector terminal. Come to common emitter configuration. So common emitter configuration is defined as if the emitter terminal of the transistor is connected in the input circuit as well as in the output circuit, then that configuration is known as common emitter configuration. If you observe the diagram, so this is NPN transistor. In this NPN transistor, N type of material acts as emitter, P type is base, N type is. NPN transistor, this emitter N type of semiconductor material is connected to input circuit as well as output circuit. In common emitter configuration, always the input is given between base and emitter. The output is taken between the terminals between collector and emitter. This is the circuit diagram. So in this case, this is emitter, this is base, this is collector. Input is given here. So this is output. Similarly, if you take common base configuration, if the base terminal of any transistor is connected in input circuit as well as output circuit, then that base is common to input as well as output, then that configuration is known as common base configuration. If you take this diagram, this is NPN transistor, emitter, base, collector. This base p-type semiconductor is connected to input as well as output, therefore this base acts as common to input as well as output, therefore this configuration is known as common base configuration. If you take the diagram for it, this is a circuit diagram. In this case, we turn the transistor in the clockwise direction or anti-clockwise direction. So this is the diagram, this is the base, this is emitter, this is collector. So if you observe in the diagram, the arrow mark is away from the base. So this is the symbolic representation of NPN transistor. That means this NPN transistor is connected in the electrical circuit in common base configuration model. In this case, base is connected to input as well as the same base is connected to output. We are giving the input between emitter and base terminal, and we are taking the output between collector and base terminal. This is the circuit diagram of common base. Similarly, come to common collector configuration. If you consider the common collector configuration, collector terminal is common in the input circuit as well as output circuit, then that configuration of the transistor is known as common collector configurations. Observe the diagram here also, we are explaining the common collector configuration by using NPN transistor only. Here N is collector as well as N is emitter. So this is emitter, base and collector. Now this is common collector terminal, therefore we are connecting this collector in the input circuit as well as in the output circuit, then this configuration is known as common collector configuration. In the common collector configuration, the input is given between a base and collector, the output is taken between the emitter and collector. This is the diagram. If you observe this circuit diagram, so emitter, base, collector. So collector is connected to input as well as output. The input is given between base and collector region, and output is taken from collector and the emitter region in the circuit. Here also the direction or arrow mark represents the conventional direction of the current. It is away from the base, therefore simply this is NPN transistor. So this is the common collector configuration in the case of NPN transistor. Thank you.